to measure it distance and per second. A slow rebound, how much it is put it back to the keeping up to the per second route, how much force. So we have a slow bumps all over the cars and a different side. If we want a right side and left side, we usually put depending on track a lot. This is one of the settings that is measured to track by track when you want to just differentiate. So if you have a lot of left side corners, you want a more bump over to the right side, because in the left you need a little bit looser control. And to contrast, if there is more right corners than left, then you just have the left more stiffer as the steering. Alright, that was a pretty simple principle of them. A fast bumper, fast rebound. Yes, there is fast bump also. The fast bump meaning that the difference in the slow and fast bump is that the fast bump is immediately the working, and the slow bump is just as the fastest slowness here. So that doesn't mean that usually fast bump have a less force than slow bump, because the fast bump is just making sure that the spring are really keeping the third spring. And then there is of course remote damping. There is a fast rebound and slow rebound in the both sides. And this rebound, of course, is once again the same in the spring and wishbones. So we have a theory of wishbones, fast rebound and slow rebound, as we have a third spring on this. It extends in a different rebound. So we have a theory also power we can set up. And it depends a lot once again on track you are driving, what side you be, and symmetrical selection. And then there is a bump damping. A fast bump, a slow bump, what's making the difference here is asymmetrical, and it depends on what side of the car you really are making. The fast bumping is a very important. Once again, understand what the curves are. A slow track, we need a loosened wheels and a less stiffer to the control mechanism. So it's a pretty simple. These are 4 different things. And then it's of course the main thing of is a ride height and springs. So we have a spring rate. This is the main element. How the wishbones and there is a suspension to push the car through. And in this kind of we are street circuit, we are making sure that we have a less spring rate. So we want to just mean that the car can adjust to the cornering. A ride height. Usually we into the slow corners, if there is a wet condition or some dirt and if there's some jumps, we always get higher the car ride height. If it's a very smooth track, if it's very straight track, then we of course want to also the track the less more lower the car is, the less it also have a ride height. Also meaning that it will be develop a downforce, a crown effect when you have very close the car, because there is a Bernoulli effect. The Bernoulli effect is if your car is just sucking very close to different material, a very high speed, it's taking already the Bernoulli effect. It's just getting the crown effect developing, because the air at the very fast. There is very small amount of air inside, and the flow over these 2 different surfaces of the track surface and the bottom of the car, and that will depend on it make the suck towards it each after both elements make a suck. This bearing level is very important to get in more. So that's why it's very important usually have a small ride height where you need a lot of downforce if you are able to do so. But there are usually regulation in sport to make it some minimum ride height in the cars. There's always check it that there is no any more crown effect cars. Crown effect car in the motorsport have a very much expanded a lot different series, because it's of course usually meaning the faster the car goes. So usually we have a different settings to the front and left and a ride height. It's depending a lot once again what kind of the car. Usually have the lower car in front, because the car maintains a better axle to the braking power acceleration. But if you can have it example to the active suspension, we can lower this acceleration. We usually bring it to the front of the car in the air a little bit higher than the down, and the acceleration, because the car is like the aeroplane wing and upside down. However, the airplane, it's opposite effect. We want to go the down, not the lift. We want to, of course, in this kind of car, we want a downforce, a lift effect. So in this, over, we are not aerodynamical, but here is the backers. Backers is the another thing, how much you want a backer to give it the response and the power in. So usually, once again, you just really higher and the right height, spring rate. More higher you are, the car also have a better straightforward speed. And then it says going to the tire pressure and campers. The campers, how the tires are, what kind of the angle towards the camper angle they have towards the track. It is a lot of different pressure variants, and it's different what kind of condition, track condition, how the car goes. But it's usually one pretty simple principle. If your tires are very much, if the cars are tracked, you can make it right changes, and otherwise there's negative and positive camper, or just a zero camper. So usually, if you want a more to the crit, you get it the negative camper, because negative camper meaning that to the top of this is the inwards and the down is, that means it's giving a more crit and more angle to the tires to stiff to the towards the track. So that's we mean, but it have a negative effect because it means that also the use of the tires, a flat bottom is more in the use, and it's a wear rate. So if there is no tire changes, the positive camper, but in motorsport, in the modern time, is the negative camper. The car tires are very usually to maximum because the tires are quite angular and quite a circular. That means it's giving it really important. Then it's a two-in. A two-in is the one of the setting to mean how much these tires in the front or a back are towards of this straight lines. And if it's two-in, it will be better control of the race. Tire pressure. Tire pressure is simple as ever, depending a lot what kind of tires you use in a different conditions. If you drive one lap, you want a very certain, but there is the most important thing is the tire pressure, how much you create a grit and a wear, and more you have a tire pressure, more it also is a wear rate. Unless you have a tire pressure also lower, but there is also coding. So higher tire pressure, the more you have a grit, but also that meaning that the cars, when the tires are getting heat, and if there is too much tire pressure, it's better to stiff the cars, and they are also looking excessive or wear rate and excessive wear rate of the tires. So you will want to be keeping the tire pressure as the balance as possible. Remember always in the first couple of laps, and it depends of the, if there is no ventilator pressure and some adjuster. If there is some adjuster, a lot of cars I haven't seen really the motorsport. So that means the tire pressure you have to be pretty different. You cannot change it through the racing. So you will be like a high tire pressure, but you will lower through the race, but you will be adjust the conditions. So the first lap when it's cold tires, you want a little bit more higher pressure, and then you want a lower pressure when the tires and air getting hotter, and already the pressure itself getting itself. And there is a soft tires. It's what kind of the so the wet tires, soft tires. It's very understandable. The different condition in qualifying you get very soft, and in the hard races, hot condition and humid heat, you need more. The tires of the hard compound, then it's a symmetrical separation, pretty simple. Alright, then it's a mechanical, aerodynamical, and this is pretty simple. As the more you have aerodynamical downforce at the wings at the levels, more it also veer. So some motor can get some 3,000 kilo power, downforce power to all the aerodynamical devices and wings, a pursuit, and the whole the body of the car. So if you want more power to that downforce, you will be also looking for the car really are produce this power. And what's the best possible the way to produce it, the downforce, is that keeping higher and bigger volume and the area of the aerodynamics. And what kind of aerodynamics we did? We have two wings usually, in the front and rear wings. In the rear wings we usually have different of the cars, and now I'm talking of the Formula open wheel cars, which are usually used in the Formula 1 and smaller Formula 2, Formula 3, Formula 3000, GP2, kart, IndyCar, IRL, and all the cars towards almost the go-karts. So